Welcome to David Alexander Maths Tuition. This is chapter 3G on regions. So this is another topic that you would have covered at GCSE, hopefully, and this is how you need to tackle them. So first of all, ignore the inequality sign. So let's write y minus x equals 3. What I want to do is write this in the form of y equals mx plus c so that I can plot it. So in order to do that, I'm going to move the negative x to the other side, so it's positive x. So y is x plus 3. So the y-intercept is 3. It's got a gradient of 1, so a long one, up 1, a long one, up 1. So it's going to go diagonally like so. And I'll just do a dashed line for now. We will worry about how we draw the lines later on. Okay, so the next one, let's turn that into just y equals 2x. So it goes through the origin, it's got a gradient of 2. So a long one, up 2, a long one, up 2, a long one, up 2, a long one, up 2. Okay, so obviously you're going to be using a pencil and ruler. I'm just freestyling this on my graphics tablet, so it might not go brilliantly. Okay, it's not brilliant, but so let's look at this last one. Y minus 1 equals negative x. So y is negative x plus 1. So it's going through positive 1, got a gradient of negative 1. So a long one, down 1, a long one, down 1, a long one, down 1. There we go. So this is our line here. Okay, so the first one is y minus x is less than 3. So if I just rearrange that, that means y is less than x plus 3. Now this is the line here, y equals x plus 3. Now if y is less than that, that means it's got to be below this line here. So it's underneath this line, so therefore it cannot be this area here, it cannot be this area here. Y is greater than 2x. Okay, so this is the line where y is 2x. It's got to be greater than that, so it's above this line. So which means it can't be this area here, or this area here, or this area over here, of course. And y is greater than or equal to negative x plus 1. So this is the line of minus x plus 1. So if the y values are greater than or equal to, then it's got to be above this line here. So it's above this line, below this line, and also above this line, then it must be this area here. This is our region that meets those inequalities. Now, when we're doing the lines, if it doesn't include if it's less than or greater than, then we do a dotted line. But if it also includes it, so greater than or equal to, then we will do a thick line. So this is the line of negative x plus 1. So if I'm drawing this properly, then this should be a thick line because it also includes. Whereas the other ones are strictly greater than or strictly less than. For those, we do a dotted line. So a bit messy, that one. But obviously if you're doing a pencil, obviously you probably wouldn't be doing all these random doodlings either, and you probably wouldn't do the arrows, but I'm just trying to make you visually appreciate the region that we need to fill in. As soon as you do the 3 lines, generally speaking, when you get a nice enclosed area, that probably is the region, but not necessarily. On a coordinate grid, shade the region that satisfies these inequalities here. So the first one is y. Let's turn it into y equals x squared plus 2x take away 3. Okay, so what am I going to do with that? So this will factorise, so that's going to be x plus 3, x minus 1. So that means the x-intercepts are negative 3 and plus 1. So minus 3 plus 1. Okay, now I also know that this is the y-intercept, negative 3 or 0, negative 3, so it's cutting through here. And I just want to work out the turning point. So to do that, I can complete the square. So that's x plus 1 all squared minus 1 minus 3, so minus 4. So the turning point is negative 1, negative 4. If you don't know how to complete the square or get turning points, then just refer back to chapter 2. So minus 1, minus 4, this is the turning point. So I can do a bit of a sketch. Again, it's going to be quite challenging using a graphics tablet. Okay, it's not really a smooth curve, it's fairly poor, but it's the best we can do. And for this one, let's just draw the line y equals x plus 3. So the y-intercept is 3 and it's got a gradient of 1. Okay, let's just, there we go. So gradient of 1, so across 1, up 1, across 1, up 1, across 1, up 1, like so. Okay, and it's strictly less than, so that should be a dotted line. Okay, in fact, the other one should have been a dashed line as well, but never mind. So where is y greater than x squared plus 2x minus 3? Well, it means it's above this curve. So it's above the curve, and it's underneath the line x plus 3. So it's below here. So therefore, this is the region we are interested in, which you might need to shade in, or more likely just label with the letter R. But that is the region we're interested in. As I said, the way I've drawn it with a thick line would be if it was y is greater than or equal to x squared plus 2x minus 3. The question was written where it's strictly greater than x squared plus 2x minus 3, so I should have actually done a dotted line. But even drawing a thick line to draw this quadratic graph proved to be a bit of a struggle, so doing a dotted one would have probably resulted in an even worse U shape. But anyway, there we go. Okay, here is another example. So we need to write this down the set of inequalities that represent region R. This is quite easy because we've actually been given the equations of the curves and the lines. So let's just work out which one's which. So the curve is the x squared plus 2x minus 3. This line here is the line x plus 3, and this line here is the 2x minus 1. So we can see that R is above the line 2x minus 1. So y is greater than 2x minus 1. Because it's a thick line, it's also equal to 2x minus 1 as well. Now if we look at the y equals x plus 3, R is below it. So therefore y is less than x plus 3, and again it's a thick line, not a dashed line, so less than or equal to. Now we can see that R is above the curve, so therefore y is greater than x squared plus 2x minus 3, and again it's not dashed, so it must also be equal to x squared plus 2x minus 3. So I suppose you could get a question where you weren't given the equations of the lines and the curves and you just needed to work them out. It should be quite easy from for the straight lines. You can get the y-intercepts easily enough, and then it's just a question of working out the gradient. The curve might be a little bit more problematic. Anyway, we didn't need to do that in this question. It's just a question of just working out whether the region is above or below the line. So is it greater than or equal to, or is it less than or equal to? Okay, so this is just the same as the previous question, except R is different. So R, let's just label the lines again. This is x plus 3. This one here is the 2x take away 1. And this is the x squared plus 2x minus 3. So R is underneath the line x plus 3. So therefore y is less than or equal to x plus 3. It's also underneath the curve. So y is less than or equal to x squared plus 2x take away 3, but it is above the 2x minus 1, so y is greater than or equal to 2x minus 1. And again, all of them are less than or equal to or greater than or equal to, because all of the lines are thick, not dashed. Okay, so again, similar question. So again, this is the x squared plus 2x take 3. This is the x plus 3. And this one here is the 2x minus 1. So the region is above the 2x minus 1. So y is greater than or equal to 2x minus 1. We can see it's below the x plus 3. So y is less than or equal to x plus 3. And it is also below the curve. So y is less than or equal to x squared plus 2x take away 3.